Hi, this is going to be multi-step equations. This will be pages 68 to, I believe, 75. Yeah, 68 to 75. I'm going to be doing a couple of problems from this packet just to help you along a little bit. So we will share my screen with you and we'll start. Okay, so here is the first page. This is more of an instructional page. I'll let you read that on your own. We will go right into some of the problems that you're going to have to work out for the pages. So this is page 69. I'm going to do the second one in the first row, 1B, I call that. So I will do that one first. Right here. So this is 3x plus 11 equals 20. So what you want to do first, always with these equations, is anything that's added or subtracted, you want to move that to the opposite side of the variable. So that's going to be your first step. So let me make a little bit of a white space here. We have a little bit of white writing room. So I'll make this a little bit bigger for us to see. 3x plus 11 equals 20. Now remember, the goal is always to get your variable on one side of the equals by itself. So again, adding and subtracting is taken away first. So in order to get rid of this plus 11, I am going to subtract 11. That's going to give me 0, right? Because plus 11 subtracted minus 11 is going to be 0. So I can only do, whatever I do to one side, I have to do to the other side. So I have to also do a minus 11 to the other side. I have to keep my equation balanced. So if I do that, now I can say basically this 11 and minus 11 is going to result in a 0. So they're gone. And on my right side, I have 20 minus 11. So that's going to be 9. And I still have this 3x over here. So now what's left is 3x equals 9. So now I'm ready to do my multiplication or division depending on what's needed. You always do the opposite of what's shown there. So I have 3 times x right now. So what I want to do is divide by 3 so that I can get the x by itself. So if I divide by 3, remember what I do to one side of the equals, I need to do to the other side. So I also have to divide by 3 on this side. And then my 3's will cancel out, leaving me with just my x, which is what I want. So now on my left side, I have x by itself equals, and then I just finish the math on the right side. 9 divided by 3 equals 3. So I have solved my equation. The x in this equation is equal to 3. So that's how you're going to do all of these. Notice that in the one right below this, you have a subtraction of 8. So your first step is going to be to add 8 to both sides. I'm not actually going to do that problem with you, but I just wanted to show you that's going to be your first step. So always check to see if you're subtracting a number or adding a number, and you do the opposite. Okay, so let's clear. The next one I wanted to do was 3c. So let's scroll down just a little bit here. So 3c is this third one here. Circle it for us right there. So let's do that one together. Make a little bit of white space here again. So let's rewrite the problem. We have negative x over 5 plus 3 equals 9. So what is my first step going to be? What do I do first? Right, I get rid of anything that's added or subtracted. So I see that I have a 3 being added. So I am going to subtract a 3. Whatever I do to one side of the equals, I need to do to the other side of equals. Okay, that will then cross these two out because a 3, positive 3 and a negative 3 will give me 0. Remember, my goal is to get x by itself. So now what am I left with? I am left with negative x over 5 equals 9 minus 3 is 6. Okay, my last step then to get my x by itself is to see what did I do. This time I divided, right? I divided an x by 5. So I do the opposite of what I'm doing in the problem here. So if I'm dividing, then I have to multiply. So I'm going to multiply by, this little dot means multiply, a 5 on the top and a 1 on the bottom. Notice how I also have this negative sign. So I'm going to actually multiply by negative 5 over 1 to get rid of the negative sign next to the x. So whatever I do to one side, I also do to the other. So I'm multiplying by negative 5 over 1, or just negative 5 on this side. I'll put it over 1 just to be consistent. And then I can cancel out these. My negative signs cancel out. 1 over any number over 1 is just the number, so I can get rid of the 1. So what I'm left with now is just the x, which is exactly what I want. And then I just do the math on the right side. I have 6 times negative 5, which is negative 30. So in this case, my answer to the problem to the right there, x is equal to negative 30. If I'm doubting myself and I'm wondering if I got that correct, I can always plug my answer back in to the problem and check that I've made a true statement. So let's just do that just to see how we'd check. So we would put negative 30 in for x over 5. And don't forget there's a negative sign there in front of that. Plus 3 equals 9. So let's solve and see if we get the answer to equal 9. So negative 30 divided by 5 is negative 6. And then again, we got that negative sign there. Plus 3 equals 9. And then an opposite of a negative 6 is really a positive 6. So 6 plus 3 equals 9. So now I have to ask myself, does 6 plus 3 equal 9? Yes, it does. So I have made a true statement. So if my statement turns out true, then I know that I have the right answer for my x. So x equals negative 30. So that's your check if you want to try that. If in doubt, always check. Okay, the next one I wanted to do was on page 71. So 71 3b, so row 3, the second problem. So if you need to pause the video to find that problem, go right ahead. And I'll make some white space. And let's try this problem. So we have a z over 2. I don't know why they use a z, because z's look so much like 2's. It can be very confusing. So z over 2 plus 6 equals 4. Okay, my first step is to subtract the 6 from both sides. Now they're telling you to use the shortcut on this page. The shortcut is just to realize that if I minus a 6 on this left side, I'm going to minus a 6 on the right side. So we can skip the minus 6 part and just go to z over 2 equals 4 minus 6. So that's the shortcut. If that confuses you, just take minus 6 to both sides. Same thing. So z over 2 equals, what is 4 minus 6? Got to be really clear on your negatives and positives at this point. Should be negative 2, correct? 4 minus 6 is negative 2. Okay, and now I've got a z and a 2. I want the z by itself. I'm dividing it by 2, so my next step is going to be multiply it by 2. Say 2 over 1 or 2, doesn't matter, times 2. These 2's will cancel out, and I'll be left with my z equals negative 2 times 2 is negative 4. So that is my answer. Z is equal to negative 4. Again, if I wanted to, I could check that. If I'm doubting myself, I can go up here and plug negative 4 in, solve the equation, and see if I get 4 out of the answer. And then I have a true statement, and I know that I did it correctly. Okay, that was 3b. I want to do 5c. 5C. I would encourage you, if you'd like, to stop and pause the video and try the problem first yourself and then come back and see if you did it correctly. So let's make a little white space here. This is 5C. So we have 3/4 n, 3/4 n plus 3. Hopefully you did this and paused the video and you already have the answer. But let's just see. Step 1, get rid of anything that's added or subtracted. I know that I have an adding of 3, so I'm going to be subtracting 3. So I'm going to just skip the step on the left side and just rewrite 3/4 n equals 9 minus 3. Why am I saying minus 3? Because I have to subtract 3 from both sides. So 3/4 n is then going to equal, what's 9 minus 3? 6, correct? Okay. And then now what do? I have to get n by itself. I'm multiplying by 3/4. So I would have to divide by 3/4. But what is division? Division is really multiplying by the reciprocal. So I'm going to multiply by 4/3. Remember, the reciprocal is take the bottom number and put it on the top, and take the top number and put it on the bottom. Whatever I do to one side of the equals, I need to do to the other. So I'm going to times by 4/3 to this side. Okay, now notice what's going to happen. These 3's are going to cancel out. These 4's are going to cancel out. And I'll be left with just n equals, and then I do the math. So on this other side here, I'm going to cancel out my 6 into my 3 there. And this becomes a 1. So I really have 2 times 4 over 1, or just 8. So n equals 8. Now, if I wanted to check that, I could go ahead and put my 8 back into the equation, solve it, and see if I get 9 as my answer. Okay, that's 71. I want to go on to page 72 next and do problem 1b. Right near the bottom here. That one right there. Make a little bit of white space again. Some more on this side, so nice clean page there. And let's see, 3y plus 5y equals 32. Okay, so they're adding a little bit of another step in these equations just because they add little by little. It's a nice curriculum because it does add it step by step, and you get confident in one area and then it says, okay, let's add this extra step now. So, okay, 3y plus 5y equals 32. So my first step now is to combine my like terms. So what are my like terms? What terms are the same? Well, we have the Smith family here and we have the Smith family here. This is 3y plus 5y. So they both belong to the same family. So that becomes 8y. 3 plus 5 is 8. Be careful on this. It's not 8y squared. It's just 8y. If you have two people that belong to the Smith family, they both have the same last name, right? Smith. It's not Smith squared, okay? So 8y equals 32. And there's nothing to add or subtract from this equation, so I can go right to my last step of dividing by 8 to both sides. So now my 8's will cross off, and I'll be left with y, which is what I want, the variable on one side by itself. And by the way, the variable could end up on the other side of an equation. That's perfectly fine. Okay, and then do the math. 32 divided by 8 equals, yep, 4. So this answer is y equals 4. If I wanted to check it, I could put 4 in for this y, and I could also put the same 4 in for that y. So I would have 3 times 4 is 12, plus 5 times 4 is 20, and I would hope that 20 plus 12 equals my 32, and it does, so I know I did this correctly. will clear. And now let's go on to page 73, row 4, problem number C. Or should I say letter number C? So this one. Okay, I'll make a little space here for us. Okay, this one looks a little more complicated, but it's not that bad. So 2/3, and I would encourage you again, pause the video, try it first, come back on and see if you got it correctly. 1/6x minus 4 equals 11. Okay, equations are getting a little bit longer. So what am I going to do first? Well, I'm going to combine my like terms. So I'm going to combine my 2/3 x and my 1/6 x. I'm going to add them together. So I can't add them the way they are because one has got a 3 on the bottom and one has a 6 on the bottom. So I have to make common denominators. So let's just go ahead and do that for a moment. 2/3 and 1/6. You probably know how to do this in your head, but if not, this is how you do it. You want to make them both a 6 for a denominator. And to do that, I multiplied the 3 by a 2. So I'm going to multiply the same 2 on the top, and I'm going to get 4, 6. And then this one can stay 1/6. And now I can add them together. So 4 plus 1 is 5/6. So now I can go back to my equation, and I know that I have 5/6 x, because I combined them. Remember, it's not x squared. That's only if you multiply. We have a plus sign in between there, so it's adding. So 5/6x minus 4 equals 11. Next step is I'm going to get rid of anything added or subtracted. So I have a subtraction of minus 4. So I'm going to be adding 4 to both sides. So if you want to just go right ahead and just do adding 4 and drop off the 4 on the left side, you can do that. I'm just going to add that step back in just to show you. So now I get 5/6x. Remember, the 4's will drop off, equals 11 plus 4, 15. And how do I solve the last step there? Change colors here. I'm actually going to erase. No, if I erase, it's going to erase my white box. So I'll just try to squeeze it in there. Okay, 5/6. I want to multiply by the reciprocal because I'm really dividing by 5/6. So that's multiplying by the reciprocal of 6 over 5. Sorry, it's right next to that other stuff, but if I erase it, my box goes away. So times 6 over 5. I'm going to try to just draw a little line so you can separate that. Okay, and the 6's will cross off and the 5's will cross off, leaving me with my x by itself. My variable is what we want to be by itself. And then I just do the math on the other side, and I take 5 into 15. That'll go 3 times. And then 5 into itself goes once. So I have 3 times 6 is 18 over 1, or just 18. So my x is equal to 18. So that is my answer to this problem right here. Again, I can check by putting my 18 back in for x and seeing if I get 11 out of that. Okay, that one was, let's clear all that. That was 4C. I want to do 7B. So let's go on to 7B here. That's this one here. Make some more white space. Okay, we have 3z. Again, we get the z's, I guess. Plus 6z. Try to make it look like a z and not a 2 as best as I can there. That's pretty good, actually. Plus 7 equals 29 minus 4. Actually, algebra is pretty fun, I think. So I think you'll start feeling that way as well. So what do I do first? I combine like terms. So what is like, or what is alike? 3z, 6z. They're alike. So if I add them together, I get 9z plus my 7 is still there, equals, and I might as well go ahead and do 29 minus 4, 25, right? And then I have an added 7, so I want to subtract 7 from both sides. If I do that, I'll be left with 9z equals 25 minus 7. What's 25 minus 7? 18, right? Actually cheated. I used my fingers on that one a little bit. Just do a quick mental analysis there. So 9z equals 18. Last step, I'm going to divide by 9 to both sides. And if I divide by 9 to both sides, the 9s are going to cross off. I'm out of screen space, but it's going to be z equals what? Go over here with it. Z equals 18 divided by 9, or 2. So z equals 2. I can plug 2 back in for z up in my original equation and check my work. Okay, just adding a few extra steps each time we go. Let's do 74, 1c. So it's the third one in the first row, the only row of problems on this page. And let's make a little white space here. Okay, so 7z, oops, undo. 7z equals 5z plus 18. Okay, what do I want to do first? Normally we would say, oh, let's get rid of the 18, right? But no, first I need to combine my like terms. They happen to be on opposite sides of the equals, don't they? So I have to move one or the other. So I can either move the 5z over to the 7z side, or I can move the 7z over to the 5z side. I'm going to choose to move the 5z by subtracting 5z from both sides. That will get rid of the 5z on the right side and add the 5z to the left side. Okay, and now if I do that, these are going to cancel out because positive 5z and negative 5z gives me 0, 0z. And 0z is just 0 because 0 times any number is 0. So now on this side I have 5z or 7z minus 5z. That will give me 2z equals what's left on the right side, just the 18. And my last step then is to divide by 2 to both sides. The 2's cross off, and I'm left with just z equals 9. 18 divided by 2. So that's how you do those. Clear? And if I clear too soon for you, you can always go back, pause it, write it down, whatever you need to do. And then I wanted to do page 75, 2 more problems, and we'll be done. Let's do 6C. This is 6C. And then I want to do 7A. Those are the 2 problems. So last 2 problems. So pause the video, do them first yourself, and come back, see if you got them right. Let's cover up everything here extra. So we got lots of writing space here, whenever we need it. Okay, z plus 1 equals 1/2 z plus 4. So z, I don't know what it is with the z's here. Especially hard with a mouse to draw a z that looks like a z and not a 2. 1/2 z, that's a 1/2, plus 4. Okay, so first thing I'm going to do is combine my like terms. They happen to be this time just constants. So 2 plus 1 is 3. Oh my goodness, it's not a 3. That's a z. That is not a 2. That is a z. Okay, so in order to combine my z's, or my constants, I have to get them together on the same side. So I am going to subtract 1/2 z from both sides, minus 1/2 z. If I do that, these guys cross off, and I'm left on this side with, this would be, remember there's an imaginary 1 in front of any variable. So we really have 1 minus 1/2. That's going to give us 1/2 z. Plus we still have our 1 equals 4. Now I can subtract 1 from both sides. Hopefully I won't run out of screen space. That'll give me 1/2 z equals 4 minus 1, or 3. And then I'm going to multiply by the reciprocal, times 2 over 1 to both sides, times 2 over 1. And that will cross off my 2's and my 1's, leaving me just with z. So it will be z equals, actually I don't want to write it there because I want to use that space for the other problem. So it will be z equals 3 times 2, or 6. So that is my answer to that problem. And the last one, do I have enough room on the bottom? I think I do. So 5y plus 9 equals negative 2y plus 30. Actually, I'll start it up here. 5y plus 9 equals negative 2y plus 30. Okay, so I want to get my like terms together. So I can either get my constants together, or I can get my y's together first. I'm actually going to get my y's together first. So to do that, I'm going to add 2y, because it's a negative 2y right now. I'm going to add 2y to both sides. These will cross off, because a negative 2y and a positive 2y becomes 0. So 5y plus 2y is going to give me 7y plus 9 equals, what's left on the other side? 30. Now I want to get my 9 to the other side by subtracting 9 from both sides. Which would be 21. And these cross off. Equal sign there. And then I'm left with 7y equals 21. And now I'm going to divide both sides by 7. And just enough space. The 7's will cancel out. I'm left with y equals 21 divided by 7, or 3. So y equals 3. So that's the last problem that I'm going to do with you. And get rid of my screen here. And hope you have a good day. See you next time. Bye.